This is America in Space, a weekly news and information program on current events dealing with the space industry. From the Washington News Bureau, here is your host, Rick Potlock.
Hello, and welcome to another edition of America in Space. February the 18th, Mars rover Perseverance is due to land in Jezreel Crater, becoming the first artificial object to land on the red planet since the Mars InSight lander in 2018, and the first rover since Curiosity touchdown back in 2012. Perseverance is carrying audiovisual equipment on board to capture portions of the pivotal entry, descent, and landing, or the EDL phase of the mission. Viewers will also be able to see the parachutes deploy, and if all goes well, a camera will show the landing. Lori Glaze, who heads the Planetary Science Division of NASA's Mission Directorate, gave a briefing for reporters on one of the key missions of Perseverance, getting samples back to Earth.
The plans for Mars sample return are multifaceted and complex, but it's exciting how our technologies have matured, bringing us to this point where we can now attempt this amazing feat. To be certain we are ready, NASA initiated an independent review board to determine if this long-awaited mission is positioned for success. The board concluded that NASA is indeed prepared for the campaign, building on decades of scientific advancements and technical progress in Mars exploration. This historic endeavor demands multiple spacecraft and our partnership with the European Space Agency, working together with a carefully orchestrated approach. First, Perseverance will drill and prepare samples for return and cache them on the surface of Mars. In 2026, a fetch rover will be launched to collect those samples and bring them to a rocket that will launch them into orbit around Mars. Another orbiter will rendezvous and capture those samples for safe delivery to Earth. If it sounds complicated, it is. If it sounds extreme, it most certainly is. The Mars sample return mission will also help us prepare for human exploration. Things like the precision landing technology, capability to launch the first rocket from the Martian surface, and being able to assess soil characteristics and toxicity are all essential to paving the way for the health and safety of our human explorers. The technology to return the samples that Perseverance collects is maturing, but NASA's investments in developing autonomous robots and landing large payloads on Mars have laid the groundwork for a successful sample return campaign.
To prepare for the landing on February 18th, NASA went to Death Valley National Park in California. Now you're going to hear three voices here. The first one you're going to hear is Andrew Johnson, the Principal Robotic Systems Engineer at JPL. Then you're going to hear from Alan Chen, the Mars 2020 Entry, Descent, and Landing, the EDL lead at JPL. And then you're going to hear from Swati Mohan, the Mars 2020 Guidance and Control Systems Engineer, also at JPL.
We are in Death Valley testing terrain relative navigation, the new technology for Mars 2020. The terrain in Death Valley is very much like Mars. It has a lot of sand dunes and steep slopes. It's quite similar to the landing site that Mars 2020 will be going to. We're taking a copy of the system that will be on the spacecraft, and we're testing it in the way that it would be used during the flight mission.
Terrain relative navigation gives the vehicle the ability to figure out where it is. This is kind of along the same lines of what the Apollo astronauts did with people in the loop back in the day. Those guys were looking out the window and looking for different craters and other features on the moon that they knew of from the maps we had of the moon. So that way they could figure out where they are and figure out where they needed to land to be safe. So for the first time here on Mars, we're automating that.
What terrain relative navigation gives you is the ability to avoid hazards that you already know about. So large hazards, hills, craters, things that you've seen before. With the camera, we take images as we're descending, and we match pieces of the image to orbital imagery that we have stored on board. And if we make many of these matches, we were able to figure out where we are relative to the map.
If we didn't have terrain relative navigation, the probability of landing safely at Jezreel Crater is about 80 to 85%. But with Mars 2020, we can actually bring that probability of success of landing safely at Jezreel Crater all the way up to 99% safe every single time.
We don't have an astronaut that we can put on board Mars 2020, but we can put this system, this terrain relative navigation system, so that the spacecraft can figure it out on its own.
I could see it being used on lunar missions, science missions, as well as human missions. Future Mars missions, of course, Mars sample return, Europa lander, landing on a comet, pretty much everywhere you want to land. You're going to want to have terrain relative navigation.
And that'll wrap up this edition of America in Space. Reporting from the Washington News Bureau, I'm Rick Potlock.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.